Hello guys, probably VOD people, considering that just started the stream. Welcome. Let me pull up chat, which never happened until the start. Mute that. Hello. Sorry, I'm not looking at the camera. Yes. Yeah, hello. Sorry we missed Tuesday. I don't know what happened. Video didn't work. So we're back. We're going to be talking about the last three sections of chapter 11 today and then the next 2 days, and then we'll spend the rest of May, maybe into June a little bit. We'll see. I need to decide some things about the schedule. The rest of May on probability, which is about odds and chance and permutations, which is important and not always obvious. So we'll talk about some games and kind of how they work and that sort of thing. Yeah, it's going to be kind of a different chapter, I think. I may use the book less and just talk about some games that I play that, yeah, probability comes up a lot in games. But it comes up in real life too, so we'll talk about that kind of stuff. Some famous problems like Monty Hall and all that kind of stuff. I see the video is lagging. That's unfortunate. Don't know if that, I can never tell if that's my internet or if it's working. Yeah. So in a minute, regardless if people will get here or not, we will talk about pyramid volume. So we're in chapter 11, which is all about volume, surface area of three-dimensional objects, things like cylinders and boxes and cones and all that kind of stuff. And we're in the math world, so everything's very clean, nice edges, perfect curves, circles, that kind of thing, to make things simpler. Because real world is a lot more complicated than the math world that we live in. Okay, so we're going to talk about cones. I want to switch to this first. Talking about pyramids and cones, which use basically the same formula, which when we were looking at cylindric volume versus volume of like a rectangle or something, it's basically the same formula. You use the base area, wherever the base is, if it's a circle or a square, a triangle, you find the area of that shape, and then you just count kind of up from it. Right? So this shape is silly. You count up, calculate the base, and just move up. With a cone, with a cone or a pyramid, we have something different. So we'll start with the pyramid. Pyramids, look like this from the top, but like this from the side. This would be the top. It's kind of, like this, and then this would be the side view. Right? They're hard to draw. I'm getting lag between my hand and my voice. That's it. Here's what it is. Misha, what are you doing? What are you doing? Okay. So if I have my pyramid base and then the actual pyramid looks something like this, right? It's triangular, and we want to calculate the volume. Which is like, how much dirt can we put in this thing? How much stone would it take to build one? What does it take to make this pyramid? Okay, so Misha, you're okay. What's wrong? I don't know if you can hear her whining. She's into the bed. She's going crazy. So the volume of this square, or this cube, would be base times the height. So volume is base times height. All right, here's our height, and then you use length and width to calculate the base. Okay? cone is obviously going to be smaller than this, and we're going to look at textbook to talk about how. Okay, because in class we would have done some other things. There's ways to prove this. You can just Google how to prove the formula for volume of pyramid. I watched that video and I was like, oh, this is probably a bit much, and I don't need to explain this to you, but you can go look that up. But here's what we're going to do. Oh, wrong button. All right, so here's the textbook. You have this textbook. We're on page 635. And here we're comparing the pyramid volume to a cube with the same base and height. Right? So they're similar. Clearly, the pyramid is going to be smaller. And then they're saying it takes 3 of these pyramids to fill up the cube. That's what this diagram says. So then we can use that to make a formula. So the pyramid volume takes 3 of them, so it's a third of the cube volume. So when we're looking at our formula here, if I have a pyramid with the same base, same height, the volume of this thing is going to equal a third of the base times the height. And this is true no matter which kind of shape you have as the base. So for any base shape, we use a third of the base times the height, and that gives the volume. That gives how much stuff, how much water can we pour in it, how much, this was a big vat, how much soup could we put in it, you know, that kind of thing. Stuff, how much stuff goes in the shape. You're making a tent. I would not suggest using a pyramid for a tent, but you're making a tent. How much room do we have? So we'd use a third of the base volume times how tall the thing is. Okay, and that's basically the entire formula for this section, because it doesn't matter what kind of base you use. And it doesn't matter if we look here. It doesn't matter if the pyramid is strictly vertical or slanted. Remember we talked about the cylinder with the coins? We can kind of slide them all over and tilt it. It's still the same volume. So we're going to find some volumes, and that's it for this section. Just using that 1/3 formula, 1/3 base times height, calculate the volume over here. Okay. So in the Dropbox, I do this every time, upload it about an hour ahead. We have this student journal page. Okay, it's got that same diagram exploration in it. I've been including explorations that I think are valuable. Here's a hexagonal pyramid, and we find the area of the hexagon, and then we find the volume. Here's what we're going to do. Here's the formula again, and then I'm going to do 3 of these problems, I think, the odd ones here. And then we'll be done for today. It'll be shorter, I think, which has been cool. Okay, so whiteboard. Remember, these files are in the Dropbox folder in a different folder than normal. So we're going to do number 1. Let's see that. Yep. Okay, so our height is 9. Here's our triangular pyramid. So like this. Then we have the height of 9 here, 9 centimeters. And then they tell us this is 4 centimeters. And then this line here is 6. Now my drawing is not the best, but it's just to give us a picture of what's in this. So this, right? So I'm doing number 1. Okay. So our volume, volume is 1/3 base times the height. We know the height is 9, and we just need to find the volume of the base. The base is that triangle that looks like this. It's 4 here and 6 here, so it's 1/2 base times height. So area of the base is going to be 1/2 times 6 times 4. That's half of 24 to 12. So then the volume is going to be 1/3 times 12 times 9, which we can simplify to be 4 times 9, so 36 centimeters. And it's cubed because it's volume. Because we multiplied 9 centimeters times 12 centimeters squared. So it's okay. I'm actually not going to do all these, or just the other ones. I'm going to skip ahead and do number 6. Yeah, number 6. So number 6 looks like this is a slanted pyramid. And okay, so we have 6 feet is our vertical here. Down, down. This is 1. This is 4. So we're going to do 1/3 base times height. The base here is a square or a rectangle, so it's 4 feet squared. 1/3 times 4 times 6, and this is going to be feet cubed, because we have feet squared times feet equals feet cubed. The volume is 8 feet. You can always check that the volume is smaller than the volume of the rectangle prism. Okay? And then we got some word problems here, so we need to be able to convert. We would spend some time in class. We would have converting kind of word language to a picture. So if you look at number 7 on the next page, a pyramid with a square base has a volume of 128 cubic inches and a height of 6 inches. Find the side lengths of the square base. So we have a square for our base, and we don't know the lengths here, so I'm just going to make an X. It's a square. They're the same. And then the height is 6. So it's height of 6. And we want to find out what X is. So our formula is volume equals 1/3 base times height. I know what the volume is. They told us it was 128. 128 equals 1/3 base, don't know what that is, well, it's x squared, times the height, which was 6. I'm going to simplify this side before I do anything, and I'm going to change this base, because it's x times x squared. 128 equals 6 over 3 x squared. This simplifies to 2, so 128 equals 2x squared. Divided by 2, 64 x squared. So x has to be, now plus or minus 8, it could be negative, but since we're talking about lengths, it's just 8, and we were in inches, so it's 8 inches. Okay? So with those, we want to convert the word problem to a picture, figure out what information we have, what it's asking for, and then solve. Okay? I think that's it for today. In terms of things I want you to know how to do. There's some practice problems there in the student journal. But the homework that I would have given, would be page yeah, this page here, page 639, 3 through 6, and 11 through 15. Okay. So this is the practice problems that I would have given, the homework. And we would also have been doing a project during this time about volume stuff that I do every year. So that's okay. But yeah, it's unfortunate I don't get to see your faces. And that's it for today. Short because it's just the one formula. Remember, the volume of something when it's a pyramid is a third times the base area times the height of whatever it is. So for a pyramid or so what's today? Thursday? So Friday, we're not doing anything. I should have grades. Switch to the screen. Should have grades updated by the end of tomorrow is my goal. Let's see about that. Probably not today, but tomorrow. And next week we will finish chapter 11, and then we'll do chapter 12 for a couple weeks, which is all about probability, calculating odds and things like that. I think next week we'll do a Zoom call on Friday, so I'll send an invite thing for that, and I'll schedule it so that the time doesn't say 6 in the morning or whatever it did last time because I have the times up. So good to see you. I hope you found some of that valuable. Remember, turn in your work. Questions, send me a remind. Questions like, can you grade my stuff, or what work do I need to do? I think you should be able to figure those out on your own. But if it's specific, like, I don't understand this math, how do I do it? Please ask for help. I am available. I've not gotten a lot of those questions. I'm assuming we're good. Well, I'm not assuming that. I'm assuming other things, but you're telling me that you're good, and so I don't know what else to do. So if you have questions, please talk to me, and hopefully see you on Tuesday.